In this presentation, we are going to look at rational and irrational numbers. So, essentially, how do you tell the difference between rational and irrational numbers? So, essentially, the rule of thumb, and it doesn't work every time now. Sometimes it can be quite tricky, but as a rule of thumb, if you can express it as a fraction, as a simple fraction of two integers, then it is a rational number. So 1.5 is rational because we can express that as the ratio 3 divided by 2, where we have two integers there. 5 is rational because it can be expressed as 5 divided by 1. 0.1111, 1 repeating, is also rational because it can be written as the ratio 1 divided by 9. Now, it's particularly those when we have decimal numbers that gets a bit tricky. We have the square root of 2 here, the fifth example here, 1.414214. That's just the 6 decimal places. Actually, the number is much longer than that. That's an irrational number. Okay, there's no obvious way. There's no way to actually express that properly as the ratio of two integers. Likewise, pi, again, is expressed there to 6 decimal places, although it's actually a bit longer, cannot be expressed properly as the ratio of two integers. Although, just to be clear, quite often in schools they would actually use this as a close approximation. It's a close approximation, it's not the exact value, 22 divided by 7. So that's a quick rundown of rational and irrational numbers. So let's just look at a question here. Given that x is an irrational positive number square root of 2, express x to the power 8 in binary notation. So this includes a bit of binary numbers here. So the square root of 2 is 2 to the power of 1/2. Okay, so when we are going to put that to the power of 3, sorry, the power of 8, square root of 2, the power of 8, equals 2 to the power of 1/2, that to the power of 1/8. That is equal to 2 to the power of 4. So we're multiplying the 1/2 by 8, that gives us 4. So that is that's equal to 16 as a decimal number. So I'm just going to add in the subscript there, 10 actually. So with 16 in base 10 is written in binary notation as 10000. Okay, 5 bits there, and that's in binary notation. Okay, so that's the answer to the first one there. Now, from part 1 is x to the power of 8 a rational number there. Is 16 a rational number there? It's written into the base 10, but it's 16. Yes. Okay, so a power of an irrational number can be a rational number. So for example, the square root of 2 squared is just 2. That is a rational number. Okay, so the answers are, again, just to be clear, 10000 to the base 2, and yes, it is. So that ends that question there.